Good day, everyone. I'm Christian Vargas, and it's a pleasure to welcome you to today's session of Encora Talks, improving the experience with Ethereum blockchain. That has been at the forefront of innovation in the decentralized finance space. Over the next 30 to 35 minutes, I will demystify Ethereum's intrinsicates, focusing on the transformative concept of account abstraction. Now, a little bit about myself. I'm a senior full stack engineer in Aura. I have 12 years of experience working on verticals across finance, retail, and hospitality. I love to continually explore emerging technologies like Ethereum and how they can solve real-world challenges. Without further ado, let's jump into the webinar to explore the possibilities for developers to interact with the Ethereum ecosystem more seamlessly. So the agenda for today, first we're going to see some of the background of Ethereum, how the current account-based model works, the type of accounts that you can have in Ethereum. Then we're going to explore the externally owned accounts wallet transaction lifecycle and some of the current limitations that this transaction lifecycle provides that are like the motive to create or to propose this new standard that we're also going to see, the ERC 4337. Then we're going to explore the main components and some of the functionalities of these components. After that, we're going to see how the transaction lifecycle looks under this new standard, ERC 4337. And then we're going to see some of the benefits and the downsides that account abstractions provides, and finally some key takeaways. So let's start. What is Ethereum? Ethereum is an open source and decentralized blockchain platform that allows developers to build and deploy smart contracts and decentralized applications, also known as dApps. The Ethereum blockchain operates on an account-based model. This model includes two types of accounts. First, there is the externally owned accounts and the contract accounts. An account-based model in blockchain refers to a system where users' accounts hold balances and transactions involve transferring a value between these accounts. As I mentioned, there is two types of accounts. First, there is the externally owned accounts, or EOAs, they work with the user having control of the account via a private key. This key is your unique signature and access pass to the blockchain account, and is usually set up using a seed phrase. EOAs enable you to send and receive transactions and interact with applications, and they can manage Ethereum balances and interact with smart contracts. On the other hand, there is the other type that is smart contract accounts that are different from EOAs by having a different build. Essentially, they are a collection of immutable code and data linked to the blockchain along with the address key. These accounts don't have a private key and are controlled by the code written by its creator. The smart contract account can also hold and manage funds, execute code, and interact with other smart contracts. But this account-based model has several problems and limitations, making the interaction with the Ethereum blockchain and managing the accounts a complex and cumbersome process for users. So let's explore some of the current limitations that these models has. So first, as we saw, today's accounts are secured using private keys that are calculated from seed phrases. So if you lose the private key or the seed phrase, you cannot recover the account. And the asset that this account controls are frozen forever. Another one is that, well, in the same way, if a person has access to the seed phrase, that person can easily discover the private key, protecting the account, and gain access to all the assets. So this person can transfer them, selling them, basically do anything that they want with these assets. Another limitation that, well, every Ethereum transaction necessitates a gas fee as a means to gauge the amount of computational work needed to execute the transactions and smart contracts. And this fee is paid in Ether, which is the Ethereum native token. This means that you will need to have enough Ether balance to process a transaction. And this can be a barrier for any new user in the Ethereum blockchain. Another limitation can be that for decentralized applications themselves, the EOAs are also very limited because batching transaction is not possible. So there is no type of automation you can do. So if I want to have my account listen to things that happen on chain and automatically do stuff, the only way to do it is with EOAs is do it by giving away my private key to some sort of centralized server, which will listen to those events and sign in on my behalf, and this will not be a very reliable or secure process to do it. Right. So let's see now a high overview and how is the experience that any user goes through in order to complete an action using the EOAs. So first, user generates and signs the transaction payload using the private key. The transaction is then gossiped to the peer-to-peer mempool via a node. Essentially, a node is like every computer connected to the network, and they ensure that everyone interacting with the blockchain has the same data. Well, then these nodes check the balance of the account generating the transaction and validate if the user have enough balance to pay for the transaction fees. Otherwise, if there is no enough balance, they reject the transaction. Then a validator picks up the transaction from the mempool and include it in a block, thus executing the transaction and storing in the blockchain. In other words, the blocks of transactions get chained together, and the data in a block cannot change without changing all the subsequent blocks, which will require the consensus of the entire network. So we can notice here this traditional life cycle of the transactions, that every transaction is generated and processed individually. And this entire process involves multiple steps and confirmations, and it's pretty tedious to complete. It's important to understand this because what the new standard tries to accomplish is to remove much of the complexity behind the scenes by replicating the current functionality of the transaction mempool. So we're going to see the new standard next. What is ERC 4337? So in Ethereum, there are two ways for proposing improvements and standards. First, there is the EIPs and the ERCs, but they have different focuses. EIPs stands for Ethereum Improvement Proposal, and it's a protocol for proposing changes and improvements to the Ethereum protocol itself. EIPs are designed to improve and evolve the Ethereum platform better to serve the needs of its users and the developers. And this process helps to ensure that upgrades are compatible with the rest of the network and don't cause any major disruptions. On the other hand, ERC stands for Ethereum Request for Comment, and is a protocol for proposing and defining essential standards to the Ethereum platform. ERCs define the rules and specifications for creating new tokens and smart contracts that can be used on the Ethereum blockchain. In this case, ERC 4337 was proposed in 2021 and was eventually authorized and accepted via governance in 2023 because it ensured zero consensus layer protocol changes. So instead of modifying the logic of the consensus layer itself, ERC 4337 tries to replicate the functionality of the transaction mempool in a higher level system. We can say that what this specification aims to use is a global entry point contract to achieve account abstraction. And what is account abstraction? So as we saw, the only way to start a transaction or execute a smart contract with Ethereum is using EOAs, and this approach has several limitations on how users can interact with Ethereum, like the difficulty to do batches of transactions or requires users to always keep Ethereum balance to cover the gas fees. So the idea of account abstraction is to enable users to utilize the smart contract wallets rather than the EOAs. So one of the main goals of account abstraction is to completely remove any need at all for users to also have EOAs. This feature will allow the users to create and manage their accounts more securely and efficiently by aiming to transfer the user authentication from the network to the smart contract and give to the wallet's creator control over how to authenticate users. We will see some of the new benefits or features later on. Now let's explore what are the main components of this new standard. So first, we have the account contract. Account contract is the smart contract wallet of a user. They can be think of like an automated assistant on the Ethereum network that, unlike the regular EOAs that need manually initiate every action, account contract can automatically perform actions based on the instructions they receive. So they can interact with other contracts, hold and manage assets, and even make decisions based on their programming logic. Then there is the paymaster. Paymaster can be any entity willing to cover the gas fees or for a specific transaction. It can be a decentralized application, a wallet provider, or any other party capable of reimbursing the bundler for the gas costs incurred during the transaction execution. The paymaster role is to ensure that the gas fees are paid, allowing the user to benefit from sponsored transactions and reducing the burden of transaction costs. Then there are the aggregators. Aggregators are optional smart contracts that work in conjunction with account contracts to validate the aggregated signatures from multiple user operations. They enable collaborative decision-making and provide an additional layer of verification for complex transactions involving multiple parties. Then there is the user operations. Think of user operations as a to-do list that you provide to your Ethereum account. This to-do list can include things like transferring funds or interact with a smart contract or even a combination of multiple actions. So in the current model, you need to manually do each item on this list, one transaction at a time. But with user operations in this new standard, you can bundle these actions together into one single operation. Sign it and then let the Ethereum network handle the rest. The bundlers, so once you create your user operations, you need someone to take this and put it into the Ethereum network for you. So this is where the bundlers come in. They are like validators who take your user operations, bundle it with others, and submit them all together to the Ethereum network. Think of bundlers as facilitators that package user operations from the user operation mempool and send them to the entry point contract on the blockchain. And finally, what is the entry point? The entry point is a singleton smart contract that acts like a gatekeeper for the Ethereum network. Once the bundler submit the user operations, the entry point is responsible for unpacking the bundle and executing all the operations. So if encounters any operation that fails, it can roll back the actions of that specific operation to ensure the integrity and reliability of the transactions. This global smart contract is like the heart of ERC 457, and it aims to simplify the logic used by the smart contracts wallets, making sure that the more complicated functions needed to ensure safety are tried and tested, allowing wallets to focus primarily on the core functionality. So now let's dive into the complete lifecycle of a user operation under this new standard and see how these components interact with each other. So in this case, the process begins when a user tries to make some action. Let's say, well, that action can come from a decentralized application or some sort of a smart contract wallet. And this action can be transferring tokens or interacting with a smart contract protocol. The decentralized application constructs the initial user operation, ensuring that all the necessary fields are populated correctly. Next, the user smart wallet is asked to sign the user operation. And here, the smart wallet can take several steps to validate the user operations before signing in. Like, well, confirm that the user has authorized previously the action. So then the smart wallet will approve the operation if all the validation pass by generating a cryptographic signature. Then the decentralized application broadcasts the signed user operation to the new alternative mempool, which is called the user operation mempool. Here, the bundles monitoring the user operation mempool will select the user operations to include them in their bundle transaction, and the bundles will perform a simulation phase, which is like a dry run, where they only are using vehicles. They're not actually writing anything to the blockchain. So the bundles will call the simulate execution of user operations in the entry point contract to ensure that all the operations are validated and have the ability to pay for the execution. So once the bundlers have select and bundle the user operation, they create a bundle transaction. And this bundle transaction represents a single transaction on the Ethereum network and is ready for submission to the entry point contract. So when the entry point contract receives the bundle transaction, it will enter to the execution phase when, again, some aspects are verified first. If this verification fails for some reason, the user operation is rejected as invalid. And this will prevent users from being able to submit improperly signed operations. So once user operation is validated, the entry point determines that there is enough prepaid gas for the user operation, and it compensates the bundler for its activities and services from this deposit. Then the operation is executed by the account contract associated with the operations, and it will perform the necessary actions like interact with other smart contracts if required, or ensure that the successful execution of the bundle transaction. After that, the user operation becomes a transaction and is sent to the blockchain to be bundled in a block. And finally, once the bundle transaction has been successfully mined and executed on-chain, all of the user operations it contains are completed. So here the users are notified their request actions have finished successfully. Right, so with now that we saw what is ERC 4327 and the new transaction lifecycle, let's see what are the benefits and negative stuff or downside or some risks that these standards provides. So first, for the benefits and the features, early we explored that, well, certain interactions with their smart contracts involve multiple steps and require multiple transactions. For example, when interacting with a decentralized finance protocol, a user might need to approve a token transfer, and then that they want to deposit that token and then perform some other action. So each step needs to be initiated separately by EOA, and this is a cumbersome and potentially costly process. So with the new transaction type called user operation, as we saw, this will allow the users to define multiple steps that should be executed as part of a single transaction. So you can have multi-operation transactions with this new standard. Another feature is that you can share the authorization credentials across multiple trusted people or devices. Then the contract can be configured so that the transactions of more than some preset value requires authorization from a certain proportion of the trusted parties. For example, there is a high value transactions that might require approval from both a mobile device or a hardware wallet before it can be accepted or processed. Then, in the current paradigm, we saw that some of the limitation is that when you lost a device or forgotten your password or the seed phrase, this means that your assets could be frozen forever. So there is this feature called social recovery that allows you to have account recovery access through previously whitelisted addresses, such as those of, well, trusted friends or family, or even you can set up hardware wallets to when you can access them to recover your account. Then there is, well, ERC 4327 also enables this concept of sponsored transactions, where someone else can pay for the gas fees, allowing like more flexibility in the transaction fee handling. So the cost of the transactions can be sponsored by someone else. Another feature is that you can specify like daily thresholds for how much value can be transferred from the account, let's say in a day or a week or by month. So this means that if an attacker does gain access to your account, they cannot like drain everything at once, and you have the opportunity to freeze and reset the account access. And well, by incorporating all these new features like pre-approval or auto-approval transactions, ERC aims to enhance the user experience overall by reducing the friction and making interaction with the smart wallets and blockchain applications more intuitive and efficient. But well, everything that had some positive aspects also have like some risks or drawbacks. So with this new standard, there is some risks, new risk that we're going to see right now. There is a slightly increase of denial of service attacks because of the introduction of more complex verification logic. There is an increase in complexity that may provide additional attack vectors. Also, compared to the regular transactions, ERC 4327 transactions may involve a slightly more gas overhead due to the added functionality and flexibility provided by the standard. However, this additional gas cost is often offset by the benefits gained, such as the support for multiple operations, making it a trade-off between the functionality and the gas efficiency that this standard provides. And while the standard supports atomic multi-operations within a single transaction, there is a restriction on queuing multiple transactions that may pose a limitation in certain use cases where simultaneous or batch transactions are required. All right, so finally, let's see some key takeaways. So account abstraction in Ethereum facilitates a smoother user experience by allowing users to interact with the network more intuitively. So the adoption of account abstraction opens up opportunities for creative fee structures, including innovative models such as sponsorship arrangements or subscription-based services. This offers the user more control over the financial interactions with the Ethereum network. And also, despite the benefits that this standard provides, it is crucial to recognize and address potential risks associated with account abstraction. So robust security measures and rigorous testing are important to mitigate the risk and ensure that a secure implementation is made and identify any vulnerability that may arise with this new standard. So with this is a wrap for today's session, and let's take it if there is any question from the audience here. All right, so what properties does ERC 4337 maintains compared to the regular Ethereum transaction mempool? Right, good question. There are several properties, but I can mention some of them. Everything is done through a peer-to-peer mempool, meaning that they're not centralized actors. Another one is that users do not have to care about or not if their wallet contract has been already published, since if a wallet does not exist yet, the first user operation created automatically. And then also another property is that, well, there is the ability to replace by fee it maintains. That means that sending a new user operation with a significantly higher premium than the old one will replace the operation of getting included faster. And we have another question. Can you elaborate on any specific challenges or considerations that developers should be aware of when implementing ERC 4337 in smart contracts? Sure. I think that, well, developers implementing this new standard can face several challenges. One could be like ensuring the transaction atomicity. This is vital for consistent state changes. Developers should design transactions to be atomic, ensuring that the transactions or execution occurs in a single indivisible operation. Another challenge could be the gas management, since the transaction may involve a slightly more gas overhead, we saw. So there is a special attention that developers should need to prevent or put attention to prevent auto gases issues. And well, lastly, another challenge could be that account abstraction may involve complex interactions with the external contracts. So developers should implement reentrancy protection mechanisms to ensure the secure external codes. Do we have another question? All right. In what scenarios does ERC-4327 account abstraction offers significant advantages over traditional approaches. All right, so account abstraction excels in scenarios where smart contracts need enhance the control over the transaction logic. Scenarios such as decentralized exchanges or I can say that, well, complex payment processing in decentralized application. As we saw, account abstraction enable a smart contract to act as a transaction sender, providing flexibility not achievable today with the traditional approach, where the externally owned accounts control the transactions. All right, so if there is no more question, thank you, everyone. I want to express my sincere gratitude to each one of you for joining me on this webinar for today. For more insightful content, please subscribe on our YouTube channel, Ancora Inc. There you will find a treasure trove of webinar and discussion. And of course, for more updates, do visit www.ancora.com. Thank you. Goodbye.